Hello. Yes, it's me. I'm going to talk to you about today's lab. This is everything you're going to need for the first three scenarios. Actually, you're going to need a few more things. You're going to need a total of 5 of these hexagonal masses. You're going to need a force sensor, and it should be set to the 10 Newton mark, which it should be and will be. Okay, on the very bottom is a pine board. Okay, that's going to be the bottom surface for all of these. And then you could say the star of the show is going to be this oak block, but you'll notice it has an it has an oak side, just the bare oak. It's got a black side, and it has a red side. So we have 3 different surface types all on one block. Scenario 1 is you're going to put the oak side down onto the pine. Now, because of the way I've taped these on here, glued them on here, you might notice there's a little bit of the red surface sticking up on one side. We don't want that. So find the side of the block that's smooth, that doesn't have the black surface or the red surface kind of sticking up. This one is not perfect, but it's good enough. Okay, so we're going to put this side down. Okay, and so what we want to do is we want to measure the amount of the maximum static friction force that will exist between this oak surface and this pine surface. Now, how are we going to measure that? Well, you're going to pull on, well, not you, but you're going to pull on the force sensor, which will cause the string to pull on the block. And basically, the force sensor will measure the required pulling force. And you're going to pull on it till you make it move. And that's it. Okay, you're going to record that data on a friction force versus time graph. Well, really, it's a pulling force versus time graph, but we've seen, hopefully, we've talked about the idea that when you pull on something and it hasn't started moving, the friction force against your pull is going to match perfectly. So we are indirectly measuring the friction force. So first scenario, you look at your data table, you'll see, okay, oak side on pine, you start with 1 block. Okay, and that's because when there's no weight on it, it gets kind of squirrely. So we're going to start out with 1 hexagonal mass on top of the wood block, and now we are ready to start collecting data. And so let's see what that looks like. Okay, so your computer person, which is me, is going to hit the collect button. You'll have 10 seconds to collect data. I'll first show you kind of the slow way to do it, and then the faster way. Okay, so we're starting to collect. First thing is, let's see if our force sensor is at 0. Okay, it wasn't quite at 0. So we want to set that to 0. So make sure you set your force sensor to 0. Okay, we'll retry that again. Okay, there we go. Okay, so it's at 0. So now we're going to stop, and now we are ready to start collecting data. So now we're going to do that. Okay, hit collect. 10 seconds. Don't panic. What you want to do is you want to begin to pull gradually with more and more and more force until it just starts to move. Well, I barely made it in there. Now, I did that very slowly, but the point is, you can see that as we pull with more and more force, the static friction force is matching it because nothing happens until the very end here. This is the point at which the block started to move. Then I reduced my pulling force and it went down to 0. I can do a much better job than that though. That's a little bit too slow. So, here we go. Let's do it again. A little bit faster this time. Okay, so I'm going to begin to pull. There, stop to move. Then you go slack. And you'll see over here, that's the peak. That's what you want to get. Now, how would you get that? Can you see me? How would you get that data point? You're going to go up here to the examine button. Then you're going to scroll along until you reach the mountain top. And something in there. Okay, you're gonna do, okay, give me a break. Okay, so basically 1.8. I would only do to 1 decimal place, 2 sig figs, that's 1.8. Now, here is a way you can take your data more efficiently because you have a lot of data to take. So what we're gonna do is, we're gonna take all 3 trials in one setting. Here we go. This is not just for professionals, even beginners can do this. Here we go. Okay, so you're gonna basically start to pull, break, release. Pull until it moves, release. Pull until it moves again, release. And you have 3 sets of data. These are 3 trials, all done in 10 seconds. So to get the actual value, you go up to examine, and you're looking for the peak. Peak, where is it? Okay, so you'll figure it out. There's the peak there, 1.4. Looks like that's peak, 1.5, 1.4. So pretty consistent there. That's how you do each trial. Now, you're gonna repeat that process by adding weight. We wanna see what happens when our surfaces are pressed harder and harder together. So you're gonna end up eventually with 5 masses on top. So you'll have to kind of figure out how to stack them sideways like this. And you should find that it's gonna take quite a bit more force, but you do it exactly the same way. Okay, that's the way you're gonna do it for the first 3 scenarios. Except of course you're going to, whatever it says in the next one, I can't remember, but if it says like red side, then you flip it down to the red side, do the same process. Then the next set of data will be the black side, do the same process. That's probably all you're gonna get today. If you get beyond that point, I will of course show you how to do the remainder. That's all I have to say, so I'm gonna leave now.